Hello everyone. Welcome to our comprehensive video guide on exit exam solution tailored for BSc graduate students. This video contains exam solutions or simply detailed solution on mathematical courses like linear algebra, calculus, differential equations, numerical analysis, algebra again, which is group theory, financial mathematics, calculus with several variables, and others. So directly, let's proceed to the first question. Question number 1 says, which of the following vectors are not linearly independent? We know that in order to answer such a question, what we have to know here is that the criteria that a vector of simply two or more vectors to be linearly dependent or independent. And you know, a set of vectors is linearly dependent if one and only if one vector can be written as a multiple of the other, or if any of the given vectors is returnable as a linear combination of the others, so that will be a sufficient condition for the given vectors to be linearly dependent vectors. So when we see option B here, we know that if we let V1 to be the first one, that's simply this one is V1, this is V2, that is 2, 0, minus 1, and 2 minus 2 to be V3. We know that the V1, that's simply 1 minus 1, 1, and this one. So that V3 can be, that is 2 minus 2, 1 can be written as a combination or simply multiple of V1, that is 1 minus 1, 2, because this one that's simply 2 minus 2, 1 can be obtained from this one by multiplying V1 by 2, which is a scalar. So that in this case, V3 can be written as V3, the linear combination of the other two, that's simply 0 times V1 plus 2 times V2. So that in this case, the set P is not linearly independent. That means they are linearly dependent vectors. Therefore, the solution or simply the answer for this question will be B. Second question, which of the following type of matrix is not triangular matrix? You know what triangular matrix is. First case, a matrix, for a given matrix to be triangular, it needs to be that of a square matrix having the same number of rows and columns, so that a matrix is said to be triangular if it is either an upper triangular or lower triangular matrix. You know that all diagonal matrices, including scalar matrix means type of matrix with some scalar quantities or simply scalars on the diagonals, but the other components are zero. Identity matrix, a square matrix whose diagonal components are exactly equal with that of 1, but the other components are still 0. And zero matrix, whenever a square matrix is zero matrix or simply zero matrix means a matrix whose every components are 0. So that they are technically both upper and lower triangular matrix. That means the scalar matrix, identity matrix, diagonal matrix, and this one that is they're all simply linear matrix are both upper and lower triangular matrices. So that in this case, in many contexts, this is a trick question as all options are triangular matrices. Therefore, the answer for this one could be all the provided option. That means just it is a bonus. That means scalar matrix by itself is a triangular matrix. Identity matrix is also triangular. Zero or simply null matrix is also diagonal, or triangular matrix. Diagonal matrix even itself is a triangular matrix. Therefore, there is no any matrix which is not probably not a triangular matrix. Therefore, all the options are triangular matrices. Question number 3. It is a question on calculus that simplify limit of a function, a limit of the rational function that's simply the square root of x squared plus 10 minus the square root of 19 over x minus 3 is equal to blank. The options are this one, that is 3 over radical 19, 6 over radical 19, 0 and doesn't exist. The given limit that's simply the function here at whenever x approaches 3 could be, that is the denominator, that is simply the square root of x squared plus 10 minus the square root of 9. Directly, if we substitute 3 in the place of x here, we have 3 squared, that's simply 9 plus 10, 19. The square root of 19 minus 19 would be 0. And again, the limit of x minus 3, that's the denominator of this rational function, at 3 is also 0, so that this will have an indeterminate form, that is 0 over 0. Therefore, applying L'Hopital's rule, that is, if we know that L'Hopital's rule stated that if the limit of the given function, that's simply this one, that is limit of x when x approaches a is equal to the limit of g of x at a. If both are 0, then the limit of f of x over g of x will have an indeterminate form, that's simply 0 over 0, so that in this case, the limit of this fraction could be the same as the limit of the derivatives of the corresponding function, that is f derivative of x over g derivative of x. So that if the limit of this function is existing, so that the limit of this function could be directly taken for the limit of f of x over g of x whenever x approaches a. Therefore, the derivative of the numerator, that's simply this one, that is the square root of x squared plus 10 minus 19 could be, we have to take the exponent, that's 1 over 2 the coefficient here. We have x squared plus 10 minus 1, that's simply 1 over 2 minus 1, that is, which is negative 1 over 2. That's chain rule, times twice of x, which is the derivative of x squared, that means, so that this is equivalent with x over the square root of x squared plus 10. And similarly, the denominator, that's simply derivative of x minus 3 is 1. Therefore, evaluating at x equal to 3, we have 3 over this one, that's simply 3 squared plus 10, which is equal to 3 over 19. 3 over 19. Therefore, the limit of the given function could be, that is the answer, which is A. Question number 4. Let f of x equal to x squared plus 2x plus 1. Then we're asked just to find f inverse of 9, f inverse at 9. That's the derivative of f inverse of 9. Then the alternatives are a is 1 over radical 6, 1 over 6, 1 over radical 3, and 1 over 3 are given. So in order to select the right derivative of this one, the inverse of the given function at this one, we have the formula, that's simply this one. Do you remember? The derivative of f inverse at y is simply exactly equal with that of 1 over the derivative of f at x, whenever f of x is equal to y. Therefore, for x squared plus 2x plus 1 is equal to 9. This implies x plus 1, which is a perfect trinomial, that is x plus 1 squared is equal to 9. This implies x plus 1 is equal to 3. That means the value of x here is 2. That means when we substitute 2 in the place of x here, that is f of 2 is equal to 9. Therefore, if f of 2 is 9, so that f inverse derivative of 9 is exactly equal with that of 1 over f derivative of 2. So that if derivative of x is equal to x plus 1, this implies f derivative of 2 could be 2 times 2 plus 2, which is 6. Therefore, f inverse derivative of f inverse at 9 is equal to 1 over 6. That is 1 over f derivative of x, or f derivative of 2, because f of 2 is 9. Therefore, the exact answer for this one could be, that is B. Okay, the next question would be the evaluation of that of the integral. Find the value of the integral of cos square x times tan cubed x dx is blank. And the alternatives are this one. So when we do the solution for this one, we have this thing that's simply the integral of x squared x times tan cubed x means, because tan is the ratio of sine and cosine, so that it could be sine cubed x over cos cubed x dx, which is equal to, further, if we simplify this one, for example, that is cos square x can cancel cos square x here, and we are left only one cos x, so that we have the integral of sine cubed x cos x dx. And then the equivalent with, but the numerator that simply sine cubed x can be written as, that is, we have sine x times sine square x. Then by using trigonometric identity, sine square x is 1 minus cos square x. So it could be sine x into 1 minus cos square x over cos x dx. Then distributing sine x over 1 minus cos square x, we have that is sine x times 1 is sine x over this one, that's simply cos x is tan x. And when we multiply this one, that's simply sine x, cos square x over cos x can cancel this one, and we have minus sine x cos x dx. Then the integral of this one, that is, we can distribute the integral over this, because integral of the sum or the difference between two functions, it is just the integral of tan x dx minus the integral of sine x cos x dx. Also, applying integration by substitution or using integration by substitution for both the integral of tan x dx and sine x cos x dx, let's assume that is equal to cos x. So that in order to determine dx here, then the derivative that is taking the derivative of both sides of this, that is u cos x, we have du is equal to the derivative of cos x, which is minus sine x dx. Then substituting these two, we have on the second one, or simply especially for this one, we have sine x equal to minus du. So that when we substitute this one here and integrate them, we will obtain minus ln the absolute value of cos x minus 1 over 2 cos square x plus any constant that is c. Because here we have tan x means the ratio of sine x over x dx, then we are letting u to be cos x, so that dx could be, I mean, the numerator that sine x dx could be minus du, therefore it could be minus ln of cos x minus the integral of this one is minus 1 over 2 cos square x plus c. And therefore the integral of this one is this thing, therefore the answer for this one could be, that is a, which is minus ln of absolute value of x plus 1 over 2 cos square x plus c. The next question. Question number 6. If the interest rate per year is 16% and the compounding occurs every quarter, then the interest rate for compounding period is A 0.04, B 0.004, C 0.4, and D is 40. Here, the annual rate R is equal to 16%, that is 16% means 0.16. And the compounding period per year, that is M, could be 4, that is simply quarterly. And the periodic rate, that is I is equal to R which is the annual rate divided by the compounding period per year, that is M. So that could be 0.16, because we are just already, we have here, that is already this one, and the compounding, that's M is 4, so therefore 0.16 over 4 could be 0.04. So that the answer for this one could be, and that is A. Question number 7. Which of the following vector is perpendicular to both? A is equal to A is equal to 2 minus 3 1, and B is equal to 1 2 minus 4. The alternatives are A 4 0 1, B 10 9 7, and 3 2 1, and lastly D we have 0 10 9. We know that in order to determine a vector which is perpendicular to both A and that of B, the only vector which is perpendicular to both A and that of B could be the cross product of the two vectors, or the negative of the cross product of A and B. Therefore, the cross product AB yields a vector which is perpendicular to both A and B. Therefore, the cross product of the two given vectors are, using this notation, that is ijk, we have the first vector, that's simply vector A, and this one is B, so that the product could be, if we expand along the first row here, it is just I multiplied by, if I delete this one in the first column, we have minus 3 times minus 4, which is positive 12, minus 2 times 1, that's simply 2, minus minus j, that's simply minus j into, if I delete this row in the second column, we have 2 times minus 4, which is minus 8, and 1 times 1, that is minus 1, plus k into, if I delete this row in this column, we have 2 times 2, which is 4, minus minus of 1 times minus 3, which is minus of minus 3, that is positive 3. Therefore, the is equivalent with 12 minus 2 is 10i, plus minus 8 minus 1 is minus 9, but this one is negative, so that it becomes positive 9j in the j direction, plus this one, that is 4 plus 3, which is 7 in the k direction. That means, this means in component, or simply in the form of ordered pair, or simply triplets, that is 10, 9, and 7. Therefore, the solution, or simply the answer for this one could be, that is B. The next question, the solution of the ordinary differential equation given by the second derivative of y plus 1 over x times the y derivative minus 1 over x square y is equal to 0 for x greater than 0 is ax the power of r, whenever r is a constant, e the power of xr, r is a constant, x the power of 1 over r, whenever r is a constant, and x the power of 1 over r is a constant. I think these two are similar alternatives. And therefore, we know that the given ordinary differential equation is a Cauchy-Euler equation, because the power of x matches the order of the derivative. That means if we multiply both sides of this equation by x squared, we have x squared times second derivative of y, x times y derivative minus minus y is equal to 0, so that we have x squared y second derivative, so therefore the exponent of x is 2, and the order of the derivative of this one is, that is 2, so that it matches. For equation of this form, that is x squared y plus x y prime plus py is equal to 0, we have to assume, or simply we can assume, that the solution of the form y is equal to x the power of r. For the case, the ordinary differential equation becomes, that's simply this one, multiplying both sides of this one, just x squared, we have this one, and that is x squared y second derivative plus x times y derivative minus y is equal to 0. Hence, y is equal to the power of r will be the form of the solution for this differential equation. Then if we let y to be x the power of r, the first derivative of y with respect to x would be r times x to the power of r minus 1, and second derivative would be y second derivative is equal to r into r minus 1 times x to the power of r minus 2. Then just to have the solution or simply the values of r, you can substitute in the place of the derivatives here, and we can solve or simplify the value of r there. Anyways, the solution form of the given ordinary differential equation is y is equal to x to the power of r. I think the solution or simply the answer for this one could be A. Next question, the general solution of the ordinary differential equation x squared y second derivative plus 2x y derivative minus 6y is equal to the raise, which is similar to the previous one, but here we are asked just to have the general solution. Therefore, in order to have the general solution again, the given ordinary differential equation is Cauchy-Euler equation again, which is similar to the previous one. And therefore, let's assume that the solution has the form y is equal to x to the power of r. Then, if y is equal to x to the power of r, then y derivative is this one, and second derivative of y with respect to x would be r into r minus 1 times x to the power of r minus 2. Now let us substitute this one, that's simply y is y prime, y double prime, that is r times x to the power of r minus 1 in the place of y prime here, and r into r minus 1 times x to the power of r minus 2 in the place of y second derivative within the original equation. Then substituting this one gives this one, that's simply r into r minus 1 times x to the power of r minus 2 times x squared plus 2 times r times x to the power of r minus 1 times x minus 6 times y is equal to 0. Then if we multiply, for example, here we have x to the power of r minus 2, x to the power of 2. So because they do have the same base, so that if we add the exponent together, the sum of r minus 2 plus 2 will be r. Here also r minus 1 plus the exponent of x, that is 1, is still r here. And we have this one, sorry. Here in the place of I, x to the power of r must be substituted. This y must be replaced by x to the power of r. So that in each term, we have the factor x to the power of r. That's this, simply this one. R into r minus 1 times x to the power of r to r times x to the power of r minus 6 times x to the power of r. Then, if we assume that x is non-zero, so that when we divide both sides by x to the power of r, since it is non-zero, then we'll obtain the function that is r into r minus 1 plus 2 r minus 6 equal to 0. Then simplifying this one, we have r squared plus r minus 6 is equal to 0. So that solving this quadratic equation, we have the value for r to be 2 or r is equal to negative 3. Therefore, the general solution for the ordinary differential equation could be just the combination of this one, that's simply y is equal to x to the power of r whenever r is 2, and that of r is equal to minus 3. So that it could be, I think the answer could be this one, that's simply c1 times x to the power of minus 3 plus c2 times x to the power of 2. For example, the first one can never be this one because the value of r is not 1. That's simply the value of r is either 2 or minus 3. So that's the exact answer for this question could be b, which is 1 times x to the power of minus 3 plus c2 times x to the power of 2 will be the general solution of this Cauchy-Euler ordinary differential equation. Okay, next. The assumption in calculating annuity is that every payment is equal and different, nominal, marginal. So in order to answer this question, we must be clear what an annuity first. We know that an annuity is defined as a sequence of equal payments made at regular intervals. And it is defined as a sequence of equal payments made at regular intervals. So that's just to simply just to make this payment made at a regular interval, so that this equality is fundamental to using standard annuity formula. Therefore, the answer for this one could be equality. That means if there exists equality here, so that the equal payment will be guaranteed there. Next question, let f of x equal to sine of cosine x, then find f derivative of x. Then the alternative that this one. So in order to find the derivative of this function with respect to x, using that of chain rule, we have d pi dx of sine of u is equal to cosine of u times u derivative whenever u is equal to cos x. Just substitution like that of integration. Therefore, if we back substitute or simply this one, that is u derivative minus x, therefore f derivative of x is equal to cosine of u, but u is cosine of x, that is cosine of cos x, times minus sine x. Therefore, it's just minus of cos x, cosine of x, sine x. Therefore, the answer could be minus sine x cos x, minus sine x cosine of cos x, that is simply b. This could be the solution. Next, what is the real rate of interest if the nominal rate is 10% and the inflation rate is 5%? The alternatives are 4.3%, 4.8, 5.3, and 5.8%. So using that Fisher equation, which relates nominal interest rate, that is, which is symbolized by I, real interest rate represented by R, and inflation rate, that's simply pi, which is given by I is equal to that's simply these are the givens. And the formula for this one, that is a Fisher equation, could be 1 plus R is equal to 1 plus I over 1 plus pi. Whenever R is the real interest rate, I is the nominal interest rate, and pi is just the inflation rate. But what we are given here is the interest rate is given to be 0.1 or 10%. The inflation rate is 5%, which is 0.05. So that in order to find R, which is the real interest rate, we have to use this formula, that is 1 plus R is equal to 1 plus I over 1 plus pi. Then substituting these values using or simply within this formula, we have 1 plus R is equal to 1 plus, 1.1, that's simply 1 plus I means, that is I in this case, I is given to be 0.1. And we have 1 here, that is 1 plus 0.1 could be 1.1 or simply 1.0 divided by 1 plus pi. Pi is given to be this one, therefore 1 plus pi could be 1.05. Then the fraction or simply the quotient of this one, 1.1 over 1.05, could be approximated as 1.0476. And this could be rounded to at this one, that's 4.8. That means it is just this 1.48, and This could be this one that's simply 1.0476 is identical with the 1.8 r. So in order to find the value of r here, we have to subtract 1 from this. So that what's left here is only 0 point r could be approximated as 1.0476 minus 1, which is 4.76, and it could be rounded to 8%. So that the answer for this one could be, that is B. Yeah, this is B. Next question. The equation 1 minus x squared y double prime, or simply y second derivative, minus 2x times y derivative plus 2 into 1 plus xy is equal to 0 is known as A. Chebyshev equation, B. Bessel equation, C. Legendre equation, Bernoulli equation. The coefficient 1 minus x squared for y second derivative and minus 2x for y are the hallmark of Legendre type differential equation. The Legendre type differential equation, that is 1 minus x squared, the coefficient of this one, that's simply this thing. We have minus 2x for the coefficient of y derivative. Therefore, they are fundamental for Legendre type differential equation. Therefore, this is a Legendre type differential equation. Therefore, the answer for this one could be C. So, as an exercise, or simply just to refresh you, just to test yourself, please justify what, or simply the form of Chebyshev equation, Bessel equation, and Bernoulli equation. Next, let a parabola antenna takes the equation x squared is equal to 160y. Then what is the area between x squared is equal to 160y, y-axis, y is equal to 2, and y is equal to 4. The alternatives are this one. So in order to determine the area which is bounded by using that of these 4 equations, we know that the area, or simply the surface, is bounded from above by y is equal to 4, and from below y is equal to 2. But bounded in between that of 4 vertically and horizontally, and it is bounded by the y-axis, the vertical axis, and the curve of x squared is equal to 160y. So we have here x squared is equal to 16y, and this implies we have the value that's simply x is equal to the square root of 60y, that is just taking the square root of both sides of this equation. Therefore, the area could be the integral vertically, that's simply from 2 to the other 4, the square root of this one, that's the square root of 160y dy, which is equal to the square root of 160 is a constant, so which we can take out from the integral, and so that the integrand will becomes the variable integral. That means only the square root of y. Therefore, the integral of the square root of y could be we can bring 1 over 2, or simply here, that is y the power of 1 over 2 plus 1 over 1 over 2 plus 1, which is y the power of 3 over 2 over 3 over 2. Then taking the reciprocal of the denominator here, we have 2 over 3 become the coefficient here. Whenever the limit of integration is from 2 to the 4, then directly applying or simply substituting the upper and lower limit of integration gives the area to be 2 over 3 into the square root of 160 into 4 the power of 3 over 2 minus 2 the power of 3 over 2, which is equal to 2 over 3. That 4 the power of 3 over 2 means 8. 2 the power of 3 over 2 means 2 radical 2. Therefore, the area could be 2 over 3 times the square root of 180 into 8 minus 2 radical 2, that is, which is identical with this one, that's simply C. So therefore, the answer could be C. Next, An investment of 9,000 today will yield 10,000 after 1 year. What is the net present value if the interest rate is 10%? Here are the alternatives: 71 birr, 81 birr, 91, and 101. What is given here is the initial investment is 9,000 birr, which is an outflow. And the future value, that's simply just after the investment, it is expected to yield 10,000 birr after 1 year, which is an inflow again. Then the discount rate is 10%, or that is 0.1. So that using NPV, that is net present value formula. The formula is net present value is equal to present value, that is the inflow minus the investment, the initial investment. That means so that the present value could be this one, that's simply 10,000 divided by 10,000 divided by 1.1 minus 9,000. Therefore, this could be, that is 9,090.91 minus 9,000, which could be 90.91. And this could be just approximated to 91. So that the alternative, that is the best answer for this question, could be, that is C. Next question, it is again limit. The limit of 1 plus sine of 4x, the power of 1 over x equals e the power of minus 4, e the power of 3, e the power of minus 3, and e the power of 4. You know that this limit has a form of 1, the power of infinity limit form. That means directly if you substitute, or simply 0 from the right side here, if you substitute 0 here, 4 times 0 from the right could be 0, sine of 0 is 0, 0 plus 1 is 1, and the exponent, the limits of 1 over x when x approaches 0 from the right side is infinity. Therefore, it has 1 the power of infinity form. So that in order to determine the limit of this function, whenever x approaches 0, we have to convert this form, that is 1 over 1 the power of infinity form, either 0 over 0 or infinity over infinity indeterminate form. So to do this, let's assume that the limit of this function at 0 from the right side is y. Then let us take the natural logarithm of both sides of this equation. So when we take the natural logarithm of both sides of this equation, we have ln y is equal to ln of 1 plus sine of 4x over x. That means ln of 1 plus sine of 4x, the power of 1 over x, means we can bring, using that of laws of logarithm, that means we can bring the exponent at the coefficient here, so that 1 over x means it is just the ln of 1 plus sine 4x over x. And then if you take this one, that is ln of 1 plus sine 4x over x, the indeterminate form for this one could be, the above could be, if you directly apply 0 from the right side, they hit 0, that's simply sine of 0 is 0, 0 plus 1 is 1, ln of 1 is 0. Again, this one, that's simply x is also x at the limit of x, whenever x approaches 0 from the right side is also 0. Therefore, this rational function has a 0 over 0 indeterminate form. So that using, or simply applying L'Hopital's rule, the limit of this one, that's simple ln of 1 plus sine of 4x over x, whenever x approaches 0 from the right side, is equal to the limit of the derivative of the numerator over the derivative of the denominator. The derivative of the denominator could be, it is ln, so that 1 over 1 plus sine of 4x, and applying L'Hopital's rule, we have the derivative of 1 plus sine of 4x could be cosine of 4x times 4. So that we have 4 times cosine of 4x over 1 plus sine of 4x over 1. That's simply this 1 means the derivative of the denominator, which is x. So that the limit of this rational function whenever x approaches 0 from the right side is 4. But this one, that's ln of this one, or simply this is equivalent to this one, that's simply ln y. That is ln y is equal to 4. If ln y is equal to 4, because we are starting by letting y to be the limit of this function. So that in order to determine y here, let us take or just raise to the exponent, that's simply e. So that's y is, which is equal to the limit of the original equation is equal to e the power of 4. E the power of 4, so that the answer for this one could be, that is D. Next, which of the following mapping T is not a linear transformation from R cubed to R square? Linear transformation, that is, we have this for transformation. So in order to distinguish which mapping is not linear or simply linear transformation from R cubed to R square, we have to know what a linear transformation or simply criteria that must be satisfied by a linear transformation. We know that a linear transformation must satisfy the image of this one, that's simply 0 under T must be 0. So when we measure this one, that's simply, for example, A here, T of 0, 0, 0 means, that means in R cubed, this could be converted into 0 minus 0, that is 0, 0 minus 0, 0, so that T of 0, 0 could be identical with 0, that simply it can be satisfied. So that this one mapping, that simply the mapping x, y, z is equal to x minus y and x minus z is linear, that means. Similarly, if we check for T of 0, 0, 0 could be 0 plus 0, that's simply every variable is 0, that could be 0, 0, so that this is also linear. But when we take this one, whenever x, y, and that of z are 0, the output or simply the image could be 1 plus 0, that's simply 1, and y is 0, so that becomes 1, 0. So that T of 0 is different from that of 0, so that and this one, that's simply different from that of 0, 0. Therefore, the mapping under alternative C is not linear, so that the answer for this one is 0. I mean C. Next, identify the error types for the following approximations. Error type. We have different error type in numerical analysis or simply numerically. So for example, this one, we have this one that is simply, that's an expansion. So we have a truncation error, or simply ignoring higher order terms. That means this f of x, y could be approximated as f of x plus h times f derivative of x, plus there are terms here, that is h squared times f second derivative of f at x plus h cubed times third derivative of f, like this. Therefore, the terms from h squared times second derivative of f of x will be ignored here, and the error which is obtained by ignoring some higher order terms are said to be truncation error. The second one, this could be, that is 3.75697 is approximated to 3.757. 3.757. So that this could be obtained from this one by rounding of 9 to the nearest number, that's simply 6. So I think it is rounding error. C, that's 3.756 is obtained from this one. So that it is just 7.569, that is 7.56. So that 9 and that of 7 are ignored. So it is just like the first one, it is chopping or truncation error. And the last one, height is equal to 8 plus or minus 0.05 5 centimeter. Therefore, the error which is created here could be, it is an absolute error. It is an absolute error. That is an error which is bounded in between the smallest and the highest one. So that truncation, rounding off, chopping, and absolute error could be the error types of this one. Next, conditions for the convergence of fixed point iteration scheme. Whenever the iterative formula is this one, that is xn plus 1 is equal to g of xn to p, and then the first one is the absolute value of g of x less than 1, the absolute value of g of x greater than 1, the absolute value of g derivative of x is greater than 1, and the magnitude of g derivative of x is less than 1. We know that for a fixed point iteration to be convergent or simply to converge, just the derivative of the iterative function, the iterative function in this case is g of xn, or simply g of x, must be less than 1 in magnitude. So that the alternative which satisfies this condition, or simply this explanation, could be this one, that's simply the magnitude of g derivative of x whenever g of x is an iterative scheme or simply formula for this method, so that the answer could be a D. Next, given as 3 by 3 matrix with two matrices, that means determinant of A is equal to 2 and the determinant of B is minus 3. Then which one of the following is incorrect? We have to select the incorrect one. The first one, the determinant of twice of AB is equal to minus 48. The determinant of A inverse is 1 over 2, and others are given here. So we have to know the relationship that exists in between the determinant of two matrices and the determinant of their product, the relationship that exists in between their inverses and transposes. For example, the first one, the determinant of twice of AB, sorry, there must be equality here. The determinant of twice of AB is equal to 2 times, I mean to the power of 3, whenever 3 is the order of the given matrix. Then that means whenever we multiply any of the matrix by a certain constant, that's simply k, so that the determinant of the original matrix will be increased by k the power of n, whenever n is the order of the given matrix. So in this case, the determinant of twice of AB is equal to 2 cubed the determinant of A times determinant of A, so that to the power of 3 is 8, the determinant of A is 2, the determinant of B is minus 3, so that this is minus 48, which is correct. But we are asked just to select the incorrect one. B, the determinant of A inverse is equal to 1 over the determinant of A. Sorry, here we have to include the equality. Here we do have equals. Here we do have also 1 over equals. That means the determinant of A inverse is equal to 1 over the determinant of A. That the reciprocal of the determinant of A, but this could be holds true whenever the determinant of A is non-zero. So, but the determinant of A is given to be 2, so therefore it is just 1 over 2, and the alternatives also say, therefore this is right, or simply it is correct. C, the determinant of A transpose. We know that if the determinant of every matrix and its transpose are the same, that means changing the rows and the elements of the given matrix will not affect the determinant of the matrix. But in this case, the determinant of A inverse, A transpose given to be minus 2, but the determinant of A is 2, so that 2 is different from that of minus 2, therefore this could be incorrect one. the incorrect one. The last one, that's the determinant of AB is equal to the determinant of the product of two matrices is the same as the product of the determinants of the individual matrices. Therefore, 2 times minus 3, which is minus 6. This is also okay. Therefore, the incorrect one is here to be. That is C. Yeah, the answer is C. That is the determinant of A transpose equal to minus 2. It must be positive 2, which is identical with the determinant of A. And the next question. The next question is, which set G with the operation indicator does not form a group? A, whole number under addition, integers under multiplication, rational numbers under addition, real numbers except minus 1, under A star B is equal to A plus B plus AB. Note, a group, this one that's simply G, with an operation that's simply a dot, is a set G equipped with binary operation that satisfies 4 axioms. That means closure property, associativity, existence of identity, and the existence of that of inverse element for each group element. So when we do or simply measure the given alternatives with respect to that is whether they are satisfying this 4 axioms or not. For example, for the first one, whole number do not have an additive inverse. We know that, for example, minus 1 is not a whole number. We know that the additive identity here is 0, so that for each and every if it has an additive inverse for each and every element, there must exist within the same set, that's within the whole set of all numbers again, that there exists at least one element that can be added with the corresponding thing just to yield 0. So when we take 1 doesn't have an additive inverse. The additive inverse is minus 1, but minus 1 is not within this one, that's within the set of all number. Therefore, the first one cannot form a group. Integers under multiplication. Integer under multiplication do not have multiplicative inverse. For example, the multiplicative inverse of 2 is 1 over 2, but 1 over 2 is not an integer. And then there are multiple invalid groups here based on the standard definitions. So that anyways, the answer is a whole numbers under addition, or even we can take this one, and that is integers under multiplication. Next question, the value of the double integral, that is a double integral of 4xy minus y cubed dA in a region bounded by y is equal to the square root of x and y is equal to x cubed is. The alternatives are this one. So in order to find the double integral or simply evaluate the double integral of a certain function, we have to take here that is simply from the integral could be from 0 to 1. From 0 to 1, the integral from x cubed to the square root of x, because y is equal to x cubed and y is equal to the square root of x are given here. 4xy minus y square, y cubed, dy by dx. That is, dA can be the product of this dy and dx. So first we have to integrate this one with respect to y. When we do this, in order to integrate, or simply when we integrate the given integral with respect to y, we have to keep the second variable, that is x, as a constant. So the integral of this function with respect to y could be the integral of that is simply y squared. Y is y squared over 2, which is 2, that is 2x y squared minus the integral of y cubed, y the power of 4 over 4, 1 over 4 times 1 over 4, whenever y is running from x cubed to the square root of x. Then when we substitute the upper and lower limit of integration, we have this function, that is the integral, the outer integral from 0 to 1 to x cubed to x squared minus 1 over 4 x squared minus 2x to the power of 7 plus 1 over 4 x to the power of 12. This one, that's simply the term or the function which is included by the bracket, is obtained from this one by only substituting the upper limit of integration, that is radical x, and the lower limit of integration, that is x squared, for y squared and y to the power of 4. Then again integrating this one and evaluating it from 0 to that of 1 we have. That means, for example, if we start from this one, the integral of 2x squared with respect to x could be 2 times x cubed over this one, that's simply over 3 here. Okay, then 1 over 52, that's simply this one, that's simply 13 times this thing. Therefore, anyways, when we evaluate 1 over here, we have 7 over 12 minus 1 over 4 plus 1 over 52, which is equal to 55 over 156. But it is minus at 0, it is everything 0. Therefore, the double integral of this function is 55 over 156. So that the answer is A. Next, which of the following statement is false concerning any group G? The alternatives are its identity element is unique. If it is a group, it is must be true. The inverse of every element is unique. AB inverse, the whole inverse is equal to A inverse times B inverse for all A and B an element of G. But I think this must be for a special group. A inverse is equal to A for all A an element of G. Now that the shoes and socks property stated that AB inverse is equal to B inverse A inverse. That means when we distribute this one over here, we have to info and then just interchange the position of A and that of B. Therefore, but C is only true for, that means this one, that is AB inverse is equal to inverse B inverse will hold is true only when the group, the given group is an abelian group, that is commutative group, so that the false statement or simply probably which may not be considered as true could be C, so that the answer is C. Next, the value of the integral e the power of x times sine x minus cosine of x dx is this one. So the answer could be, let us take this one, that is the derivative minus e the power of x cosine of x. Then if we apply derivative of the product of the functions, this is simply the same as the product of the first function, that is the product of minus e the power of x is itself multiplied by the second one, which is minus e the power of x cos x plus the derivative of the second, that is the derivative of cosine of x is minus sine x and multiplied by this one, that is minus e the power of x, minus times minus could be positive, e the power of x sine x. Therefore, e the power of x, if we factor out e the power of x at the common factor, we have e to the power of x into sine x minus cosine of x. And this matches, or simply this is identical, or simply this could be matched for the integrand perfectly. That means if the derivative of this function is exactly identical with the integrand of this function, so it means that the integral of this function is the thing that is minus e to the power of x cos x plus any constant c, so that the answer could be that is, I think it is A. A the answer. Next, let f of x is equal to x squared plus b if x is greater than or equal to 1, and minus x squared x cubed if x is less than or equal to minus 1, less than minus 1. Then find the value of b if f is continuous. This is a characteristic equation. F of x is 2x squared plus b if x is greater than or equal to minus 1, and minus x cubed whenever x is less than minus 1. So we know that a given function that is f is said to be continuous at the given point, that's simply point b, whenever b, a function is defined at this point, and also the limit of the given function is existing and equivalent to that of its functional value at b. That we know that a function is continuous at b if and only if limit of f of x when x approaches b exists and equal to f of b. But the limit of the given function, that is minus x cubed, whenever x is approaching to that of minus 1, is positive 1. And f of minus 1 is equal to twice of minus 1 square plus b is equal to 2 plus b. But this is equivalent with that simply the limit is already 1. Therefore, 2 plus b is equal to 1. This implies b is equal to minus 1. Therefore, the correct alternative for this equation, whenever the value of b, which can make this characteristic equation to be continuity, that b needs to be minus 1, so that the answer is D. Next, which of the following statement is false? Again, it is algebra question, one group theory. For any group G, for any A an element of G, there exists n an element of Z, such that A to the power of n is equal to the identity element E. If G is abelian, then AB, the power of n, is equal to the power of n times B, the power of n. Okay, anyways, A is false because it only holds 4 elements of finite order. That means if the group is an infinite order, so that the element with that is infinite groups have infinite with infinite order. Therefore, the false statement could be this one, but the rest, if G is an abelian group, then A b the power of n is equal to a the power of n b the power of n, or b the power of n times a the power of n. If a square is equal to e, then for all n element of G, then G is an abelian group, of course, and any cyclic group is abelian. Any cyclic group is an abelian group. So the answer is A. Next, solutions are independent if and only if the Wronskian is 0, not equal to 0, 1, and 2. What is the Wronskian first? We know that the Wronskian W of y1, y2, y3 of any differentiable functions is the determinant of the matrix formed by the functions and their derivatives up to order n minus 1. If we have n number of differentiable equations, that means. Then the Wronskian of linearly independent solution to homogeneous linear ordinary differential equation can never be 0, or simply it must be non-zero. Therefore, if the definition for, or simply the application of Wronskian is this one, so the alternative which matches with this definition could be, I think this one, that simply be, it must be non-zero simply, not equal to 0. So the answer is B. Next, the maximum of f of xy is equal to xy the power of 6 on ellipse x square over 4 plus y square is equal to y at y square is equal to okay, in order to find the maximum of this function subject to this ellipse at y square, we want to maximize f of xy is equal to x the power of xy times the power of x times y the power of 6 subject to this ellipse at y square. Here we must simply let's assume that let's replace a new variable y u is equal to x square and v is equal to y square. Then the constraint becomes that is the equation of the ellipse, but depending on the new variables will be u over 4 plus v is equal to 1, which implies u is equal to 4 into 1 minus v. And substituting into the objective function x square y square is equal to uv, which is equal to 4 into 1 minus v times v, which is 4 into v minus v square. Then now let's maximize the resulting function of v, that is g of v, which is equal to 4 into v minus v square. That is g derivative of x in order to maximize it, or just to maximum value. G derivative of v is equal to the derivative of this function with respect to v, 4 into 1 minus 2v. This is already 0, then this implies this could be 0 only when v is equal to 1 over 2. This means the maximum occurs when v is equal to y square, or simply 1 over 2. 1 over 2. So the answer could be, I think it is D. At this point, that's simply 1 over 2. Question number 29. If phi is a homomorphism from group G to group G prime, then which of the following is incorrect? These are the alternatives. So the image of phi is a subgroup of the target group G prime, not the domain group G. Not the domain group G. Therefore, the incorrect one could be this one, that's simply C. But the rest are, if phi is homomorphism from group G into group prime, the phi of E, that is the image of E, could be A prime. Phi of A inverse is equal to phi of A inverse, and kernel of phi is subgroup of G. But this one is false, because the image of phi is a subgroup of target group G prime, not the domain of G. It's not the domain of G. Therefore, the answer is C. And next, which of one of the following is an integral domain? So in order to answer this question, we must be clear first what an integral domain is. You know that an integral domain is a commutative ring with unity that has no zero divisors. An integral domain is a commutative ring with unity that has no zero divisors. So that the n is said to be an integral domain if and only if n is a prime number. Because if n is an even number, that means the unity, so that the commutative ring will have zero divisors, but it will be without or simply no zero divisor whenever n is a prime number. So that 7 is the only prime number within the given alternatives. Therefore, the 7 is an integral domain. An integral domain means that is a commutative ring with unity and has no zero divisors. So that the answer is Z7, which is B. Next, dual objective function of the minimum Z is equal to 2x plus 9, such that 3x plus 5y greater than or equal to 3 and 9x plus 5y greater than or equal to 8. Here we are given the primal problem Z is equal to 2x plus 9 subject to the constraint 3x plus 5y greater than or equal to 3 and 9x plus 5y greater than or equal to 8. We know that the structure is a minimization problem with greater than or equal to. That means its dual will be maximization problem. Minimization over here, that's greater than or equal to, will be maximization. So that let's assume that U and W be the dual variables, the new variables, and we know that the dual objective function uses the right-hand side of the values of the constraint. That means the right-hand side value could be, that is 3 for the first constraint and 8 from the second constraint. Therefore, they maximize C, which is equal to 3U plus 8W, whenever U and W are the dual variables, and 3 is the right-hand value of the first constraint, and 8 is the right-hand value of the second constraint. Therefore, sorry, the answer for that means from the coefficients x and y, we have 3u plus 9. It's not v, rather it is w. 9w less than or equal to 2 whenever the x coefficients are 29, and 5u plus 5v less than or equal to 9 whenever y the coefficients are 5 and 5. Therefore, whenever u and v are greater than or equal to 0 and greater than the primal constraints, the primal constraints there is no here, greater than or equal to 0 dual variables. Therefore, the answer for this could be this one, that's simply B, which is C, 3U plus 8W. That means this one. The next question. The next question says, if X is a decision variable of LPP, that is linear programming problem, and unrestricted in sign, then this variable can be converted into X is equal to X prime minus double prime of X. So as to solve the linear programming problem by simple X method, where this one. We know that the standard simplex method solves maximization linear program problem in a standard form. That is, the standard simplex requires non-negative variables. Therefore, we have to select from the given alternatives the non-negative variables. For example, here x prime greater than or equal to 0 and x double prime greater than or equal to 0. Probably this is negative, but in this case here, B, since the double prime of x is less than or equal to 0, this may have a possibility to be negative. This is also negative because of x prime is less than or equal to 0, so that the only thing that which is non-negative and satisfy the condition of standard simplex could be this one, that is A, which is x prime greater than or equal to 0 and double prime greater than or equal to 0. So the answer is A. Next question, before formulating a linear programming model, it is better to express constraints in orders or verbally identify the variables, express objectives in words, and all of the above. Just as a definition, just before formulating linear programming model, it's better to express the constraints in words, that is which constraints, how many constraints we are using, verbally identify the variables. We have to verbally identify, or simply must be clear on the identification of variables, express the objective in words. So that all these three are very fundamental just to formulate linear program model. So all of the above could be the answer for this question. Next, in simplex, if all pivot column entries are less than or equal to 0, that is then positive. Then the type of simplex could be degenerate, alternative optimal, and bounded and visible. That is simply A. The simplex is said to be degenerate if one or more basic variables is there in the right-hand side column. If in the right-hand side column of the simplex is 0, so that could be degenerate. Alternative optimal, whenever 0 in 0 they draw Cj minus Zj is equal to 0 for non-basic variables. Unbounded, if all entries in the pivot column is less than or equal to 0, no positive entries here. And visible, phase one objective, that is artificial variable remain, no basic variable solution exists. So the answer could be whenever this one are non-zero, I think it's unbounded because all entries in the pivot column are less than or equal to 0. So the answer could be that is C, which is unbounded. Okay, next. While solving an linear program defined by n variables and m equations, whenever m less than n, through simplex method, basic solutions are determined by setting n minus m variables equal to 0 and solving m equations to obtain solution for remaining m variables, provided the resulting solutions are unique. This means that the maximum number of the basic solution is what we're given here is, or what we're asked here is, we are asked just to determine the maximum number of basic solutions of this linear programming problem. We know that in simplex method, a basic solution is obtained by selecting m variables called basic variables. The remaining n minus m variables are said to be 0. So that the number of ways to choose m basic variables from n variables is this one, that's n choose m choose n, or simply just which could be written or simply calculated as n factorial over n minus m factorial times m factorial. So that the answer for this question could be, which matches with this one could be, I think it is B. B, that's simply n factorial over n minus m factorial times m factorial. The sum of the positive divisors of 48. We know that the positive divisors of 48 are, that is 1, 2, 3, 4, 6, 8, 12, up to this one, that's simply 48. All these are positives. So the sum of the positive divisors of 48 means we are asked just to determine the sum of these dividers. So that their sum could be this one, that's simply 124. 124. So that basically or simply obviously the answer is A. Or using divisor function formula, that is sigma of n, we have prime factorization of 48 is the prime factors are to the only to n that of 3, which is to the power of 4 times 3. So that the sum of this would be to the power of the first prime factor of this natural number, the power of the exponent of this 1 plus 1 minus 1 to the power of 5 minus 1 into 3 squared, because the exponent of the second prime factor of 48 is 3, that which is 1. So that's 3 squared minus 1 over 2 minus 1 times 3 minus 1, which is equal to 31 times 4, which is 124. In both cases, the answer is the same, which is 124. So that's the answer is A, which is 124. Next, which linear congruence has a solution? A linear congruence, that is 3x is congruent to 2 modulo of 6, 4x congruent to 1 modulo of 6, 2x 4 modulo of 6, 5x this one. So for a linear congruence, x is equal to b modulo of n. The solution exists if and only if the GCD of a and n divides b. That means the criteria for a linear congruence of this form, that is x equal to b modulo of n, to have a solution, or simply for the existence of a solution for this one, this linear congruence will have a solution if and only if the GCD of the coefficient of xa and n divides this one, that's simply b. So the number of solutions is equal to the GCD of an. That means if this condition is satisfied, if the linear congruence has a solution, that means, and the number of solutions of the linear congruence will be obtained by the GCD of a and that of n. That means the solution for this linear congruence will exists only when the number of solutions of this one divides b. Therefore, now let's check that. Let us check them. For example, the first one, that is 3x is congruent to 2 modulo of n. Here, the GCD of a here is 3, and this one is b, and 6 is n. So the GCD of 3 and 6. 3 and 6 is 3, and but 3 doesn't divide b, that's simply in this case 2. Therefore, no solution, or simply this 3x congruent to 2 modulo of 6 doesn't have a solution, or simply the solution doesn't exist. But if we take C, we have 2x congruent to 4 modulo of 6. The greater count factor of 2 and that of 6 is 2. 2 divides 4. That is, 4 is a multiple of 2. That means, therefore, it satisfies. And the number of equations could be, that is, the greater common factor of 2 and that of this one, that's simply 6, which is 2. So that this linear congruence will have 2 solutions. Therefore, the answer is C. Okay, octal expansion of this number. Octal means that's simply in base 8. Then in order to find the given number in base 10 to another numeration system, we have to step-by-step conversion method, repeated division by 8, and taking the remainders from bottom to that of top. So let us start from this one, that is 12,345. When 12,345 is divided by 8, the quotient, that's simply the value is 1,543, and the remainder would be 1. Again, take the quotient here, divided by 8, 192, and the remainder which is obtained here is 7. Then again take the quotient here and divide it by 8. Then we have 24 and with the remainder 0. Again, let us divide 24 by 8. Sorry, this is it is just mean 24 divided by 8, that's simply 3. The remainder here is 3, 0. And again, 3 divided by 8. 3 divided by 8, the remainder is 0. The quotient is 0 and the remainder is this one, that's simply 3. And therefore, when we take or simply take the remainders, only the remainders which are obtained at this step, at each division step, from bottom to top, we have 30071. 30071, therefore, this could be 30071. That's simply A will be the answer for this question. Okay, next. Solve solution for 6x plus 9y is equal to 10. A0, P1, C2, and D, and infinite. You know that the given equation is linear Diophantine equation of the form x plus py is equal to c. And the given equation will have an integer solution, that is solution which are integer. That means if and only if the GCD of the coefficients of the variable divides the constant, that's c. Therefore, what we are given here is we are given the equation which is 6x plus 9y plus is equal to 10. Therefore, the GCD of the coefficients of x and y, that's got the GCD of 6 and 9 is 3. But 3 doesn't divide this one, that's simply 10. So that this will be a sufficient condition for this linear Diophantine equation not to have an integer solution. That means it doesn't have an integer solution, but the given equation will have infinite real solutions. Therefore, the answer is D, infinite real solutions. Next, which one of the following is an alternative method for linear equations? Sorry, which one of the following is an iterative method for linear equations? Corresponding Gauss-Seidel method, Gauss-Jordan method, Gauss elimination method, LU decomposition method. So let us see one by one. We know that Gauss-Seidel is an iterative method, which is successive approximation or successive iteration. Next, Gauss-Jordan is a direct method, which depends on the reduction of the coefficient matrix into an identity matrix. And Gauss elimination is also direct method, which bases on the reduction of the given coefficient matrix of the given system of linear equation into upper triangular matrix by using that of row reduction. And LU decomposition, it is also direct method, which depends on factorization method. Therefore, the only iterative method for system of linear equation could be Gauss-Seidel method, so that the answer for this question could be A. Next, Newton-Raphson method is used to find basically derivatives, roots of equations, integration, and all. Here, Newton-Raphson method is used to find roots of nonlinear equations of the form f of x equal to 0. And the formula, the iterative formula for this method, that is Newton-Raphson method, could be xn plus 1 is equal to xn minus f of xn over f derivative of xn. So the iterative method, or simply this one, that is Newton-Raphson method, used the derivative of the given function at the approximate value, but it doesn't find the derivative of the given function, or the objective of the method is just to find roots of equation. Therefore, the answer for this one is B, which is roots of equation. Next, for convergence of Newton-Raphson method, f of x times the second derivative of f at x over the square of f derivative of x must be less than 1, greater than 1, 0, and 1. We know that Newton-Raphson method convergence, or simply Raphson convergence condition. For quadratic convergence of Newton-Raphson method, the following must hold true near the approximate root, or simply near the root of the given equation. That means f of x times second derivative of f at x over the square of the derivative of x must be less than 1. The magnitude, that's simply in magnitude, it must be less than 1. That means if this condition is satisfied, so that Newton-Raphson convergence, or simply Newton-Raphson method, will converge to the exact, or simply the better approximate root of the given linear equation. So that the answer could be, that is A. Next, the value of the double integral again, that is x plus y dx dy, could be 3, 4, 2, and 1. You know that by using that of step-by-step integration, the region for integral could be first. This one, that's 0 from 0 to that of 2 is 4x, that is x must be within 0 to that of 1. And from 0 to 1, that is this line of integration, or simply could be for the outer variable, that's simply y. So that y must be 0 less than or equal to y less than or equal to 1. Therefore, now let's integrate step by step. First, if we integrate it with the inner one, that is with respect to x, that is keeping y as a constant, we have the integral of x plus y. The x from 0 to that of 2 could be is x squared over 2 plus yx, since we're assuming that y is a constant, because we are integrating this one with respect to x. So that only the variable of integration could be x. So that this could be whenever x is running from 0 to that of 2. But when we substitute the upper limit of integration for x and 0 for and 0, so that at 2, this could be 4 over 2, that is simply 2. We have here that's simply 2y, but at 0 it's already 0, therefore we have 2 plus y, 2 plus 2i. And again, integrating the result, that is 2 plus y with respect to y, that is keeping x at the constant. We have the integral from 0 to 1, 2 plus 2y dy, which is equal to the integral of 2 with respect to y is 2y, plus this one to y could be y squared over 2, that times 2, which is y squared. Then the substituting the upper limit of integration over here, 2 times 1 is 2. We have 1 squared, that's simply 1, and at 0 it's 0, so that 2 plus 1 will be 0. I mean 3. Therefore, the double integral of this 1 over this region of integral is said to be 3, that's simply this one. Therefore, the answer is A. And next, the rational derivative of f of x, y, z is equal to 4x minus 3 e the power of 3x z in direction of 1, I mean minus 1, 4, 2 at 3 minus 1, 0 is this one. These are the alternatives. So using the rational derivative formula, we have the directional derivative of f in the direction of u is equal to the gradient of f dot vector that's simply u, whenever this one is the unit vector mostly. But u is given to be minus 1, 4, 2, because we are asked just to find the direction derivative of this one in the direction of this at this point. And the unit vector in the direction of this one, or simply this vector, could be u, which is equal to minus 1 over square root of 1, this one, because the square root of 1 could be obtained by taking the square root of the sum of the square of minus 1 plus 4 square plus 2 square. Therefore, and f of x, y, z is given to be this one, then we have the gradient of this one, that is the partial derivative of f with respect to x, y, and that of z could be the partial derivative of f with respect to x could be, that is the derivative of this one. We have we have 4 here, and this could be e the power of minus 3x times 3z, and therefore we have 4 minus 3z times e the power of 3xz. The partial derivative of f with respect to y, because it is constant, or simply there is no y here, so that becomes 0. And the partial derivative of f with respect to z is this one. Then the gradient of f at 3 minus 1, 0 could be obtained from this one by only replacing 3 for x, minus 1 for y, and 0 for z. So when we substitute this point, that's simply this point over here, 4 minus 3 times z times e the power of 3xz, because already this one is 0, therefore the 0, so that the value of x is 4. Second one is already 0, it's 0. And the last one here, minus 3x, minus 3 times x. X index is 3. So that's 3 times minus 3 is minus 9. But e the power of 3xz, since z is zeros, it becomes e the power of 0, which is 1. 1 times minus 9 would be minus 9. Therefore, 4, 0, minus 9 is the gradient of the given function, this function, at the point 3 minus 1, 0. Therefore, the directional derivative of f in the direction of the unit vector u could be 4, 0, minus 1, that is the gradient of the given function at the indicated point, times the unit vector of the directional derivative, the directional vector, which is equal to minus 4 over the square root of 21 plus 0 plus minus 18 over 21, that is 4 times minus 1 over 21 is minus 4 over 21. 0 times this one is already 0. Minus 9 times this one is minus 18 over 21, which is equal to minus 22 over the square root of 21. Therefore, the answer for this question could be, that is A, minus 22 over the square root of 21. Next, curvature of circle with radius A is a square, the square root of A, 1 over A, and twice of A. Note, the curvature K measures how sharply a curve bends. Therefore, in the case of that of a circle, for a circle of radius A, the curvature K of a curve is given by the formula that is 1 over A whenever A is its radius, that is the radius of the circle. So that larger radius, when the radius of the given circle is large, so that its curvature, that's K, will be 1 over a very large number could be small. So that generally, and it is a general curve with small curvature. But when the radius of the given circle is very small, the curvature, or simply the curvedness of the given circle, could be sharper curved or sharper curve, and the magnitude of the curvature could be very large, or simply large curvature. That means when the curvature is large, the curve is sharp. When the curvature is small, so that the curve of the given circle will be less sharp or simply gentler curve. So that the answer could be, that is 1/n, which is C. This question is selecting a false statement about Jacobi versus Gauss-Seidel method, that is on numerical analysis. First one is Jacobi value modified next iteration. Jacobi requires fewer iteration used for dominant systems. Dominance is sufficient. Convergence for any initial guess. Gauss-Seidel generally converges faster than Jacobi because Gauss-Seidel method is a real modification of this one that's simply Jacobi. Therefore, this could be fasterly converges to the exact root of, or simply the better solution of the given equation plan. This one that's Jacobi, so that B, Jacobi requires fewer iteration is false. That means only Jacobi, that simply this is false. So the answer is B. But the rest are true. Last one usually gives a smaller error in numerical derivatives. Forward difference, backward difference, central difference, all the same. Truncation error in central difference is order of h square, while forward, backward difference are order of h. So usually smaller error could be a central difference is more accurate than the others. Therefore, the answer could be, that is C, which is central difference. Okay, that is all what I have for today. Please don't forget just to subscribe the channel and like, comment, and share the video for your friends. Thank you.